Hi guys, so this week we're looking at asymptotes. We only have 2 lessons this week. So this lesson 1 is our Wednesday lesson. I'll probably do both lessons one after the other. So once you get this one, you should have both available. So this lesson we're looking at vertical asymptotes, and next lesson we're looking at horizontal asymptotes. So before we get started, I would like you to find all the possible values of x for this particular formula. So x squared minus 3 in brackets times in bracket x minus 2. So work out what that is, and it all equals 0. Okay, so with this week, we are looking at what are called rational functions. So rational numbers include fractions, and rational functions are basically fractions here. So these are not polynomials because remember, a polynomial can only have degrees that are positive integers, whereas this here is a x to the negative 1, so that's not a positive integer. Okay. Now remember, you can never divide by 0. So if x ever becomes 0, then this entire thing becomes undefined. Okay, and this is not something that we've come across before. This kind of just not being able to solve it, and that is an asymptote. So basically, a point of the function where you cannot define it. So if we want to actually plot this, we want to make x equals 100, y equals 0.01, x equals 1, y equals 1. As x gets closer to 0, y becomes larger, but if x becomes 0, there's just nothing. So, and if x starts from negative 100, negative 100, negative 1, if x starts from negative 100 and gets closer to 0, you'll see it goes to negative infinity. But when it gets to 0, you can't define it. So it approaches positive infinity here, it approaches negative infinity here, but at 0, you can't define it. And that's what we call a vertical asymptote. Okay, so all we need to do to find a vertical asymptote is find what x has to be to make the denominator 0. So in our first example, the denominator is 1 minus x. To make that 0, we have to have x equal 1. To have 1 minus 1, 1 minus 1 is 0. Therefore, this function here is undefined when x equals 1. Therefore, the vertical asymptote is at x equals 1. You can sometimes have multiples. So we have 1 minus x squared, whether x is 1 or negative 1. That doesn't change the fact that x squared equals 1, so 1 minus 1 is 0. So at x equals 1 or x equals negative 1, this is going to be an asymptote. Okay, so it's relatively simple. What I would like you to do is I'd like you to find the asymptotes for these 4 functions here. Should be relatively straightforward. All you're wanting to do is make these denominators equal 0 and find out. For these, there will be multiple, for some of them, there will be multiple x's to make those denominators 0. So what I'd like you to do is I've already received one of these and it was great. Thank you, McKelty. So choose one of these 3 and explain why you think it should be included in the curriculum or removed. And that was actually a great read. So if an electric rotor has 3,000 revolutions per minute, how many degrees does it rotate in 1 second? Relatively simple reading activity. Okay, so what I wanted to do just to finish off this video, because this has been quite a short video, is I'm going to pop into Desmos and show you what these actually look like on a Cartesian plane. And then there's Moss. Okay, so 1 over a minus x. Oh, a minus x. Okay, so I'm just doing a minus x just because. And what I want to do, if I make a bigger, then the asymptote moves further. So if if we have 1 over 6 minus x, if x equals 6, then it's going to be undefined there. So we can actually kind of move it back and forth that way. And if we wanted to, we could do x squared. X cubed. So yeah, just have a bit of a look around this. And we could even go a take x, b plus x, decided for b, and we can make these both go a little bit crazy. So this is a function, but it is not a polynomial. But anyway, have a bit of a play around with this as well. It's really good for visualizing. Anyway, I'm going to quickly move on and make the second lesson for this week. So you guys will have both of them one after the other.